So hello students, welcome to EduTap and welcome to the 5th lecture of ARD static series. Today we will be discussing about the soil and water conservation, and in this particular topic we will talk about the component of soil. Okay, we have seen NABARD had repeatedly asked the questions, and even this time from the component of soil there was some question. Okay, so repeatedly from this particular topic the question appear. Also that's why the topic becomes very important for your NABARD phase 2 examination too. Okay, moving to, if you are new here, do remember to subscribe to our YouTube channel, and if you want the PDF of this video you can join our Telegram channel too. So moving to the first question of today's class, the composition of air in the soil is how much? So we all know, if soil is there, if anything is there, that is made up of some components. Okay, basically soil has different components that we will talk about in the lecture. So here we are talking about one of the component, that is air. So you will have to tell how much is the composition of air, that is also known as soil air. Okay, and it is in the soil pores. So here they are asking ki composition kitna hota hai usually in general cases for this air. So here we are talking about, is it 80%, 60 to 65, 50 to 80, 20 to 30%, or is it 10%? Good afternoon everyone, welcome to the class. So do let me know the answer please. So Albert is going with the 20 to 30%. So D, okay, so most of you are going with the option D, and you will be absolutely correct. The answer is 20 to 30%. How you can remember it? See, there is a quite easy trick that I will tell you, and there will be no need to remember it again and again or to revise it. Okay, we will see the trick in a few minutes, but before that, talking about the soil. So basically the definition of soil. So if you are starting a question in the mains too, so first of all you should define the soil. So what is soil? It is defined as the dynamic natural body on the surface of the earth where the plant grows, so life is supported from there. Okay, mineral and nutrient cycle is there, so because mineral get composed, okay, organic matter is there, that get decomposed too. Mineralization also happen, decomposition happens, so all that processes are going under the soil surface. So talking about the soil, so we all know lithosphere is there. So in lithosphere we all know the earth is divided. Talking about the crust of the earth, that is the topmost part of the earth. And if we talk about the composition, as you can see, the most percentage is covered by the oxygen. So that is 46%, more than 40%, 46% oxygen, maximum oxygen is there. But surprisingly, it is not pure oxygen O2 that we see, that is atmospheric oxygen. Usually this oxygen is present in some other compound. Okay, किसी और minerals के साथ, किसी और, let's say there is Al2O3. So in this kind of form oxygen is present, but overall percentage of oxygen is very high. Then second is your silicon. Then you can see other component too, and these are basically more than 98%, only these components are. Okay, moving to the now composition of soil. Since we are discussing the soil, that was about the earth crust. It means topmost layer of the earth. Now we will discuss about the composition of soil. So first of all, you should know that when we are talking about the soil, there are two components, and these components are pore space and solid space. Pore space means the empty space, and these are the solids. Okay, talking about the solids, so solids are basically almost 50%. In 50%, 45% is the mineral component and 5% is the organic component. Talking about the air and water, so they are sharing the pore space. Okay, so here is a very interesting thing that happened. The relationship between the air and the water is inverse. Okay, it means, see, there are limited seat. Let's say there are 3 pores, or let's say there are 6 pores. So if only one pore is covered with water, so other 5 will be covered by air. On the other hand, if let's say 5 are covered with the water, so air will cover only one pore. Okay, so there are numerous pores, so we won't be counting it, but the overall relationship is somewhat, it is inverse. So how you can remember it? See, remember the percentage. Since 50-50 is there, easy it is. So 45-5 you can go for organic and mineral and organic part. For air and water, just remember the 25%. So this is the range, but if your similar amount is given, the definite amount is given, just say 50 ka aadha 25-25. So half of 50, 25-25. So let's go with the 25% water, 25% air. So that's how you can remember it. This is quite easy part. Okay, so now we will move to further difficult part. Now first of all we will talk about the solid part. So the next question say, which of the following statement is correct? Since we have discussed it, so you will have to tell. I think you will be able to guess the answer. So mineral is the largest soil component. First, so we have try to remember the pie chart that we have discussed. उसमें highest component कौन सा था, largest portion किसका था, try to remember that. You will know if the statement is correct. The second statement say the crust of the earth contain more than 40% of oxygen. So two things you will have to know, the component and the percentage. Is it correct? Primary minerals are those soil material that are similar to the parent material. Okay, what kind of rock your soil is from? So in nature वहाँ रहता है. Minerals are naturally occurring solid homogeneous substances composed of atom having orderly and regular arrangement with the definite chemical composition and characteristic and geometric form. Example, quartz is there. So you will have to tell the last one is the definition, that is point D. Okay, so that you can understand. We will not further discuss the definition of the mineral itself, but it is to make you understand. So everybody till now is going with the option E, that is all of the above, and that is absolutely correct. Very good. So 2 out of 2 marks are there for the question 2. So I commend you for that. So moving to the mineral part, let's see. So there are two. We have discussed the definition. Largest portion is the mineral. We have discussed it is 45%. So primary mineral, what are these? These are sand silt that we know, that we discuss. Okay, primary material these are, and their nature is similar to the parent material from where they have been withered. Okay, so they can be, because they are new comparatively the primary one. It means they come the first. पहले हम primary school जाते हैं, then we go to secondary school. So this kind of thing you'll have to remember. The primary one is they have often irregular shape because they are new. Okay, moving to the secondary, what will happen in the primary nutrient? The process will go on and they will stabilize somewhat, and we will see this such as silicate clay. We will find such kind of structure. Okay, so that was about the mineral part. That is the largest part. 45% of mineral in the soil component is there. Moving to the next question now. Which of the following statement is true? Organic matter releases the nutrient in the plant available form upon the decomposition. The end product of decomposition is humus, a black rumbly material resistant to the further decomposition. Most soil organic matter originates from the plant tissue. So 3 statements are given here. So here we are talking about, since we have discussed about the mineral part and we have also discussed the definition. So here what we are discussing the remaining 5%, the organic part. Among the 40% solid, 45 we have seen ki mineral part tha, 5% organic part is there. These statements are regarding that. Okay, so try to attempt this question 2. So here the options are given and everybody is going with the option all of the above, and that is option E. Okay, so very good. Albert is gone with the D option. Okay, so do know that everything is correct and you should know. Okay, I do understand why the third one you might not have known, so we will discuss it further. Okay, moving to the organic matter part. First you should know that where the organic matter come from. कोई भी living organism है, okay, rather it is plant or animal. So they will provide you, rather in the form of excreta or after their death, in the cycle they will provide the organic matter. Okay, this organic matter, see, we already know that in a balanced system what happened, the primary producers are always more. When we are talking about the biomass, the plant have larger biomass. Okay, so that's why when we are talking about the organic matter, most part come from the plant part. Okay, now you won't be confused ki why plant part is more in the organic matter part. Then what happens, some of the part, okay, plants, we can't eat all the part of the plant and we can't consume all the plant even itself. Okay, so if you are talking about the wheat, we will take grain and the stubble part we will left it. Okay, so what will happen, so a plant will provide the primary nutrient, then the animal are said to be the secondary source, because what is happening, they are consuming the primary source and then they are providing the secondary source. Okay, so that is why organic matter, the largest one is plant, then there is animal. Then we should know some other part too, that new organic matter is mineralized and decomposition of these materials provide the available nutrient. Okay, we always talk about कि nutrient एक तो है कितने. Then we also talk about the available nutrient to the plant. We all know that the nitrogen gas is highest in the atmosphere, but still the plant can't take it, okay, because it is not provided in the available form. So available form should be there, and that is done by the decomposition process. So plant tissue, natural condition में, okay, everything act as the residue. every part of the plant or the residue act as the source for the decomposition. So various manure is there. Then things you should know about this is, see, first of all, what will happen, we are adding fresh residue. This residue is being consumed and converted by the living organism that are already provided in the soil. We also call it soil biota. Okay, so these organisms are feeding on the fresh residue, then it will become active particle, then this will turn into humus, and this humus is the final form. Okay, this is very stable, and this will all the processes that are going on, mineral related processes that are going on, say nitrification there is, okay, denitrification is happening, the phosphorus cycle is going on, so that all is happening in the humus. So humus is very important, and water holding capacity is also affected by the organic matter, especially the humus. So moving to the next part now. So question 4 says, which of the following is the rhizolic water? Read it very carefully because this is not very straight question. Okay, read very carefully, take your time, don't hurry up and don't attempt the answer wrong. So water is water that is found in the macropores, water that is found in the micropores, water that is available for the plant growth, the water that is present in the space between the soil particles, water that is held tightly as a thin film around the soil particle by the absorption force. So we have discussed we have read all the options. Try to attempt it very carefully. Okay, this might be a little confusing. Take your time. Okay, you have let's say I'll give you 30 seconds. Since I have read it, I know you all might have read it. Okay, so answers started coming. See, the correct answer will be, of course, see there is confusion. The correct answer will be your option D. That is the water present between the space, in the space between the soil particle. Simply the other name or the other term for the rhizolic water is your soil water. Okay, it includes all the water that is there, that is soil moisture, soil water is there. So water present in the space simply. Okay, we have talked about how air and water has the inverse relationship. So it is regarding that. Okay, so soil moisture, again we all know, influence all the character or all the characteristics, whether it is physical, chemical or biological characteristics of the soil. So there is soil water. Then again we know soil moisture का directly impact किसमें पड़ेगा? The water available for the plant. Okay, so that is directly affected by the soil water that is present in the soil. Then you can see temperature is maintained, humidity is maintained by how much soil water is there in our soil component. Okay, then again see also the air, the presence of air. If soil water component or the water part is too much, the air part will be too low. So moving to the next part now, we can discuss what kind of water are there. So you should know gravitational water, capillary water and hygroscopic water. So those of you who know what are these, very good. Those of you who don't know, just try to remember the term itself and we will understand the term so that you can have a better grasp of the concept. See, when we are talking about the gravitation, what is gravitation? No problem, Albert. See, what is gravitational force? That is pulling us down. Okay, so that is gravitating us toward the earth. So whatever water that comes under the influence of the gravity, okay, gravitational force of the earth and move downward. Okay, so if something fell, it moves toward the downward direction. Okay, it moved down in downward direction. Similarly, in gravitational water, under the influence of gravity, water moves downward. It means whatever pores are there, so water will move through them and it will move downward. Usually the water is present in the macropores, and since it moves very rapidly under the influence of the gravity, the water is not usually available for the plants. Moving to the capillary water, see capillary, what happens when water moves due to the pressure difference among the tubes. So capillary water is resistant to the gravitational force. Okay. Some other forces are there, let's say cohesion and adhesion forces are there, and against the gravity the water is present in the soil. So this is not getting affected by the force of gravity. That is why it is capillary water, and since it is not moving downward, it जा नहीं रहा है, available है वहाँ पे. So this is the only water that will be actually available to the plant. So you can read about it here. Okay, in simpler terms I have told you capillary water वो है जो रहेगा. Gravitation होने के बाद, gravity लगने के बाद भी that is there. So talking about the hygroscopic water, What is hygroscopic water? So this is the water that is very tightly held. Say there are some ionic forces and adhesion forces, because of which this water is totally unavailable to the plant, and this water is present under the very high pressure. Okay, say even when there is a high dry condition, the plant cannot consume this particular water. As you can see, it is not available to the plant. It is bound very tightly. Okay, the gravitational water moves very easily, and this particular hygroscopic water doesn't move at all. So this kind of things are there. Rajeshwari, please explain yourself again. How can I explain the proportion? If you are talking about how much gravitational water is there, capillary water is there, hygroscopic water is there, so I don't think there will be much to discuss again. This particular availability of these water, see, depends on many factors. First of all, what kind of soil you have. Okay, what kind of conditions are there. If some active components are present in there. See, what will happen, let's say in a similar term, if you talk about the sand particles or the sandy soil, so in that case what happens, the pore size is very high, so of course the whole water have very good space. Okay, so water will move very easily, and the gravitational water will be higher comparing to the capillary water and hygroscopic water. Next, if you are talking about the clay soil, what will happen, there are very tubes. Okay, tube like structures are there, so what will happen again, rather they will be able to resist the gravity by the force of capillary water. So when we are talking about the clayey soil, capillary water will be higher than the gravitational water and the hygroscopic water. Another exception here is if there are actives present that can react or bond to the water directly. In that case, what will happen, or if there are hygroscopic component present, so they will absorb the water, and water will not be available to the plant. So in that case, hygroscopic water will be there. Okay, so that is why the component like how much gravitational water, capillary water, hygroscopic water is there, I haven't discussed it yet. So I hope that is clear. So now let's move to our next question. If the soil is saturated, the gravity water start moving downward when all the gravitational water has been drained. Okay, yeah, that is the pressure. Rajeshwari, that is pressure. That is a different thing. So the pressure is become due to the holes or the pores that is present. So what will happen, if we are discussing about the capillary water, let's say the tube is very narrow, in that case the force will be higher, again the water will be less available to the plant. And if let's say the pressure is lower, the lower the pressure, plant will be easily able to snatch the water from the capillary tubes. Okay, so that is that. So now moving to the question, when all the gravitational water drained away and then the wet soil is almost uniformly moist, the amount of water held in the soil in the stage is known as, okay, answer is already given. I'm really sorry. The correct answer is your field capacity. Okay, let's talk about the field capacity now. Very good. So field capacity is the amount of moisture the water content held. So we have talked about the gravitational water, capillary water, hygroscopic water. Now what happened? Let's say there is a raining condition, and after some time in the rain-fed condition or in the after irrigation even, what will happen after 2-3 days? You will, first of all, what will happen initially in the top layer, there will be too much water, and in the bottom layer or in the deep layers they will be comparatively dry. Then slowly under the force of gravity, water will start moving downward. Now what will happen, the deeper layer will have more moisture, and top layer the water has been moved, also the evaporation has occurred, so moisture content will be low. So if the condition persists, let's say for 2 or 3 days, after 2 and 3 days, what will happen, there will be a uniformity that how much moisture is present to the soil. Okay, that means if you take the soil let's say from 2 centimeter and 2.5 centimeter, you will find out that there is a uniformity, there isn't much moisture change. Okay, so that condition is your field capacity. So field capacity is ideally how much water is available to your plant. Okay, ideally I have said, I will told you why I have said ideally when we will discuss the further other topics. So that is the field capacity. So that when I have told you what happened, let's say this is the saturation condition, when all the pores are filled with the water. So no more water can be held by the soil. So that is your saturated condition. Now what will happen under the gravitation? The water that was about to move has been moved. Now the water is present in the pours very ideally or very uniformly. Now this is the field capacity, and since all the water that should be gone is gone, this is the maximum water that can be available to your plants. Okay, plants maximum में किसी field से कितना पानी ले सकते हैं, that is your field capacity. So okay, so moving to the next question now. So as the soil water content decreases, the plant begin to wilt. Okay, of course पानी कम हो गया, then plant started to dry out. So at this stage, what will happen if the plant is kept in a saturated atmosphere? Now what we have done, let's say there is a raining condition and you have a plant in the home. So you were out for some vacation, you came there, the plant is wilting. So but there is raining outside, you can't go outside. So what you did? There's moisture in the atmosphere and you put the pot of the plant, pot that contains the plant, in that atmosphere. So what will happen in that condition to the plant, you'll have to study. Will the plant regain its turbidity immediately, or will the plant will still wilt, or the plant will initially what will happen, will have no effect and slowly it will start regaining its turbidity, or the plant will die immediately, or the fifth case scenario is the plant will first of all will regain its turbidity, but due to some pressure it will started to wilt. So you'll have to tell. So answers are coming. It's a case scenario. You can guess the answer if you don't know. Of course we will discuss it and you'll be able to get it correct. But what do you think? Just try to use some common sense or some kind of logic. So it will be good for your brain. So all kinds of answers are coming. Very good. That is very encouraging. Okay, seems like you are understanding the concept. Very commendable. Let's see what will happen in this particular case. The plant will still wilt. Why? Because we haven't given the water or provided the water to the soil from where the plant can absorb. We have only said कि atmosphere में पानी है. Plant won't, the root won't come out of the plant and start absorbing the water. Okay. So what will happen? Let's say you are not taking good care of your plant. In that case, what will happen? Your plant will start with. So in that condition, you thought कि okay, I'll keep it in the saturated atmosphere. Okay. But the plant will not start regaining turbidity unless the water is applied to the soil. But there will come a point, the plant is wilted for so long or waited for the water to be available for so long that when you added the water, the plant will not regain its turbidity at all, no matter how much water you provide. So that will be a permanent wilting point. So you can see what are the wilting points, the state at which occur, wilting point it will be there, and percentage head will be called as wilting coefficient. Okay, so that was your wilting point, wilting coefficient, and what you should not do when your plant is wilting. So we have discussed it all. Moving to the seventh question, the maximum amount of soil water the irrigated managers choose to allow the crop to extract from an active rooting zone between the irrigation is called what? So let's say you have irrigated your crop and you are manager of the farm. Okay, this was let's say second irrigation you have given. Now, for how long you will wait till you give the third irrigation? So this particular time period, what it will be called, is it management allowable depletion, maximum allowable depletion, maximum allowable deficient, all of the above or none of the above? Okay, what we do, we are expecting at this point, since you have irrigated, or let's say there is a raining condition, your field is at field capacity, but that doesn't mean it will it will last for very long. Plant will not be able to consume 100% of the field capacity. Evaporation is going on there. Okay, some other processes are going on there. So option are coming between the B, C. So the correct answer will be here all of the above. So these three are the similar kind of term that we use. So you can see from here the maximum allowable depletion or deficit. That is MAD, you can also see the term. That is also known as management allowable depletion. So what is this? This is the maximum amount of soil water that you will allow. कि ठीक है इतना सूखने देते हैं field को, then I'll start watering the plant. Let's say अभी soil का color you see कि it is somewhat very dark brown. So what you say कि okay, I'll wait till the color will fade away 2 shades or 3 shades. Let's say it's your way to understand it. So that time you have allowed, that will be the maximum allowable depletion, or at the water loss you have allowed. So that will be maximum allowable depletion of water that you have allowed. कि जब 50% water let's say evaporate हो जाए, I'll start third irrigation. You say okay, जब third irrigation से 20% हो जाए, I'll start fourth irrigation. That kind of condition. Simply understanding it through the chart. Let's say this is your field capacity at 100%. Okay. इसके अलावा if you give water, what will happen? It won't be get absorbed. So irrigational water, gravitational water is gone out. So what will happen? You will wait till 40 to 50% of field capacity is gone. You won't wait till 0% आ जाए, because when your plant is between 0% to 40%, it is already under stress. The water is available, but plant has to do extra work to absorb that water. So what you will do, when your water percentage or the soil moisture, let's say for 50% of the field capacity. So field capacity, let's say 50 liter field capacity है your field की, you will wait कि जैसे ही 25 liter moisture हो गया, you will provide irrigation and again put it to 50 liter. Okay, so that is the concept of MAD, that is maximum allowable depletion or deficit or management allowable deficit. Okay, to simply understand it, do remember to okay, notice this one. This particular chart, this is very important. I have told you कि कैसे इसको understand करना है, so you can revise through it very easily. So after building point, the water available below that will not be available to plant. That is hygroscopic water. Above it is gravitational water. So this is the water available. If the blue line is crossed, that means your plant will permanently wilt. It won't it won't regain its turbidity again. So you will have to see field capacity से कितना आप allowed कर सकते हो कि your plant won't be stressed to absorb the water. Now moving to the next question, which of the following factor affects the soil air composition? So now we are moving to the last factor of soil component. So is it wetting or drying, or is it swelling or shrinking, or is it tillage or compaction, aggregation or dispersion, or is it all of the above? Okay. Priyanka, we will discuss this kinds of discussion that is not related to the topic. We will do it at the end of the video, okay? And don't worry, we are planning to come up with a video where we will only discuss the source and the question that you have and the strategy that you should attempt for the ARD section. So just wait for that video. We will give detailed discussion there will be of how you should study and what you should study from and what topic, even the topic we will discuss, okay? So the answers are coming about E, all of the above. So those of you who don't know, just try to understand the concept. So here we are talking about the soil and air, and the people who have attempted the answer, very good. You all are absolutely correct. The correct answer is all of the above. Okay. Now discussing this particular topic, see, when we are talking about the soil air, so what affects your soil air? The condition of soil. If your soil is wet, of course the air will be low. If your soil is dry, it means the good amount of air will be there. Then swelling and shrinking. Okay, when we talk about the clay soil, we all know it swelled very easily. Okay, then if shrinking is there, of course the pore size, when we talk about swelling, what will happen? The pore size will increase. Of course it will be able to hold more air. When we are talking about shrinking, the pore size will decrease and it will be able to it won't be able to hold as much as air like before. So talking about tillage, compaction, if compaction is there, again the pore space will be less available, and tillage के लिए more available. Then aggregation and dispersion is there. So these kind of factors that affect the soil water, soil air. So other thing you should know about that, we all know pore space are limited. Again, water is competing with the air. So if amount of water increase, air will decrease. If air increase, water will decrease. Then we should know the field air capacity is fractional volume, how much field air should be there. The things you should remember is these 2 points. Okay, these are some factual points that you should remember. In sandy soil, what happened? 25% or more is your soil air. When we talk about loamy soil, 15 to 20% is the soil air. And when we are talking about the clay soil, less than 10% is there. Why? Because we all know that clay soil has good water holding capacity. Okay. Water holding capacity, and it has poor drainage. So पानी अच्छे से drain नहीं होता है. So water is already holding much of the space. So space for air will be low. Then other thing you should know that this when the oxygen content of the soil is limited, the growth of the crop is affected. When we are talking it reach below 2%, it becomes very hard for crops to grow. Okay. Then there is example of rice. See, in rice what happened? It can grow, germinate and grow well even in the 0% oxygen. Okay, so that is the exception you should remember. And some crops like tobacco, linseed, they need more oxygen, while on the contrary rice, it doesn't need any kind of oxygen or very low oxygen, it can survive well. Most plants need 2%, so these are the factors you should remember. Now it is time for your homework. So I hope you all will attempt the questions. So these are 2 homework questions. I want to know if you are revising, and I also want you to do some research. So we have talked about the soil today. We all know soil is what? Powerhouse of all the reactions that are going on in the soil and the nutrient availability of the soil. So when we are talking about the nutrient, we all know nitrogen is a major nutrient. Okay, very essential nutrient it is. So we all know process of nitrogen again. N2 say NH3 is formed. Sometime NO2 is formed. Then NO3 is formed. NO3 is formed. Then sometime denitrification happen. Again N2 is formed. So these are the nitrogen cycle. What you'll have to tell. You will have to, if you know, do attempt the question in the comment section. Okay, I'll respond to your question. So those of you who will attempt the question right, I'll provide them with the answer. Okay, you have provided the answer right, so there will be like for you if you have provided the correct answer. The question says which the process of conversion of ammonia to nitrate. Do remember what is nitrate? It is NO2. What is nitrite? NO2, nitrate, NO3. So NO2 to NO3 is known as nitrification. You will have to tell which of the following microorganisms show this nitrification process. Okay, it's your optional: Nitrosomonas, Nitrobacter, Nitrosospira, Nitrosococcus, or Nitrosolobus. Okay, you'll have to tell and attempt the question in the comment section, not in the chat box section. In the comment section, I'll respond you. Okay, if you are seeing the video, you have 24 hours. So tomorrow I'll respond, or I'll also provide who have given the correct answer. Now this was the homework question that you'll have to tell. Now time is for revision question. So we have discussed in the 3rd lecture about the SRI. So here we are talking about the rice. So I have given you a table where the spacing was provided. Okay, row spacing was provided. You'll have to tell the spacing in SRI method of rice is how much. So these are your options. And if you know the answer, very good, do attempt that in the comment section. Okay, I'll respond to the comment. And if you don't know the answer, where you can find the answer, go to the lecture 3 of seed and sowing, the crop geometry. In the last slide we have discussed this particular topic. I have given you data. Again, the facts are very important. Do try to remember them. Okay, so that was it for the lecture. Do remember to comment that. Okay, I'll see who have given the correct answer. No, I won't respond it right now, right here. And this is your revision question, this is your homework question. दोनों का आंसर मुझे चाहिए, especially the people who are live. Okay, you people are regularly attending the class, so make okay, वहाँ पे present रहना है. So I want you all to be there. So thank you so much for attending the lecture, and I hope you'll enjoy the lecture. If you like the lecture, do let me know that. Okay. Homework is done when you have commented that, okay, the answer, the correct answer, of course. If you don't know the answer, just do a little research. That will be good for your studies too. Okay, so thank you so much for attending the lecture. And that was all. If you have any query, do remember to write to us. Okay, at hello@edutap.co.in, and do check our Telegram channel too for the PDF too. So thank you so much and have a nice day.